linear equations. And there are a bunch of ways to graph linear equations. And what we'll do in this video is kind of the most basic way, where we'll just plot a bunch of values and then connect the dots. And I think you'll see what I'm saying. So here I have an equation, a linear equation. I'll rewrite it just in case that was too small. Y is equal to 2x plus 7. And I want to graph this linear equation. Before I even take out the graph paper, what I could do is set up a table where I pick a bunch of x values, and then I can figure out what y value would correspond to each of those x values. So for example, if x is equal to, let me start really low. If x is equal to minus 2, or negative 2, I should say, what is y? Well, you substitute negative 2 up here. It would be 2 times negative 2 plus 7. So this is negative 4 plus 7. This is equal to 3. If x is equal to, I'm just picking x values at random that might be indicative of, I'll probably do 3 or 4 points here. So what happens when x is equal to 0? Then y is going to be equal to 2 times 0 plus 7 is going to be equal to 7. What about, I just happen to be going up by 2. You could be going up by 1, or you could be picking numbers at random. When x is equal to 2, what is y? Well, it'll be 2 times 2 plus 7. So 4 plus 7 is equal to 11. And I could keep plotting points if I like, but we should already have enough to graph it. And actually, to plot any line, you actually only need 2 points. So we already have one more than necessary. Actually, let me just do one more just to show you this really is a line. So what happens when x is equal to 4? And actually, just to not go up by 2, let's do x is equal to 8, just to pick a random number. Then y is going to be 2 times 8 plus 7, which is, let's see, well, this might go off of our graph paper, but 2 times 8 is 16, plus 7 is equal to 23. Now, let's graph it. So let me do my y-axis right there. That is my y-axis. And let me do my x-axis. Let's see, I have a lot of positive values here, so I want a lot of space on the positive y side. So that is my x-axis. And then I use the points x is equal to negative 2. Negative 2, that's negative 1. That's 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are our x values. And then we can go up into the y-axis. I'll do it at a slightly different scale because these numbers get large very quickly. So maybe I'll do it in increments of 2. So this could be 2, 4, 6, 8, 10, 12, 14, 16. And I could just keep going up there, but let's plot these points. So this first coordinate I have is x is equal to negative 2, y is equal to 3. So it's the point, so I could write my coordinates. It's going to be the point negative 2, 3. X is negative 2. Y is 3. 3 would land right over there. So that's our first one, negative 2, comma 3. Then our next point, 0, 7. Let me do it in that color. 0, 7. X is 0, y is 7, right there. 0, 7. Then we have this one in green here, point 2, comma 11. 2, comma 11 would be right about there. 2, comma 11. And I have this last point. This is actually going to fall off of my graph. 8, comma 23. 8, comma 23, that's going to be way up here someplace. If you can even see what I'm doing. This is 8, 23. And then if we connect the dots, you'll see a line form. So let me connect these dots. It should be. I've obviously hand drawn it, so it might not be a perfectly straight line. But if you had a computer do it, it would be a straight line. So you could keep picking x values and figuring out the corresponding y values. In this situation, y is a function of our x values. And if you kept plotting every point, you'll get every line. If you picked every possible x and plotted every one, you'd get every point on the line.